Good morning, students. Today I am going to teach you polynomials. Okay. You have already studied this chapter in your standard 9. Okay. Uh, uh, so I do not like to tell you more. Let me start from the definition of the polynomial and go into the topic. Okay. What is polynomial? It is an algebraic expression and its general form is an x to the power n. Here an is called coefficient, x is called variable, n is called exponent or power. Here n is a whole number. Okay. So let us take some examples. Suppose I have written 4x to the power 3. Okay. So here 4 is coefficient, this is an, and x is this is variable, and 3 is called power or exponent. So it is a polynomial. Okay, and this polynomial is of one terms. Similarly, you can take other example 4 x to the power 3, 2x, 3. Okay, it is how many terms? It has 3 terms. 4x square one term, 2x one term, and 3 one term. Please observe here each terms. Okay, each term is of the form n x to the power n. Here in the first term n equal to 4, x is variable, and n equal to 3. In the second term n equal to 2, x is variable, and here power is not written. Generally we do not write, it is power 1. So it is also of the form n x to the power n. Similarly in 3, this is the third term, this also can be written as, okay, see, this can be written as 4x to the power 3 plus 2x to the power 1 plus 3 into x to the power 0. It is also written in the form of 3 into x to the power 0, and the value of x to the power 0 equal to 1. Okay. So each of the terms has general form an x to the power n. Okay. Let us discuss the classification of polynomials. Polynomials are classified. First one is basing on terms, number of terms they contain, and second one is the power. Okay. Or that is known as what? Degree. Basing on terms, these are of types monomial, binomial, trinomial. Okay, it has one term only, and binomial has 2 terms, and trinomial has 3 terms. Whatever the power may be. Take the example of 3x to the power 5. Okay, so it has only one term, so it is monomial. Here you can take 5x to the power 2 plus 3x. It is binomial. Other example, you can take 3x plus 2, whatever the degree may be. Okay. In trinomial, you can take 3 terms. 5x to the power 2, 2x plus 3. Okay. So this is the classification of polynomials basing on terms. Next, basing on degree. Okay. And what is the, suppose I want to tell you what is the degree of this polynomial. Okay. So here, listen, xh power 2, also xh power 1. But you have to consider the highest power of the variable. So degree of this polynomial is, okay, 2. Here the degree of the polynomial is 2, here the degree of the polynomial is 1, and here the degree of the polynomial is 5. So, based on degree, these are also classified as linear, quadratic polynomial and cubic polynomial. Basing on degree. Okay? First one is linear, means it is power 1, or x to the power 1, you can take it. Second one, quadratic. Okay, it is a 2x square 3x plus 4, whatever the number of terms may be. If you vanish these two terms also, if the polynomial is only 2x to the power 2, it is also quadratic. Okay. It doesn't depend on the number of terms, but it simply depends on the, okay, number of degrees, number of powers. And this is what? Quadratic. Similarly, you can take cubic polynomial. In cubic polynomial, you have to take the power equal to 3. 3x to the power 3, 5x plus 6. Okay. Also, in addition to these 3 polynomials, another polynomial is there whose degree is 0. 0 polynomial. Okay. 0 polynomial. You can take the example 2. 2 is a 0 polynomial because 2 can be written as 2 into x to the power 0. Okay. This is equal to 2 into 1 equal to 2. So, these are the classification about polynomials. Okay. So, today we will study the graphs of the polynomial. You already know that the graph of linear polynomial is a straight line. Today we will discuss the graph of quadratic polynomial. What is the nature of graph of quadratic polynomial? Listen, it has general form ax square bx plus c. Okay, ax square bx plus c. And when you equate this one with 0, it will be what? Quadratic equations. And here a doesn't equal to 0. This term should not be 0 in case of what? Quadratic polynomial. Other term may vanish, it doesn't matter. So, if you take some examples, let us take an example y equal to x to the power 2 minus 3x minus 4 is a quadratic polynomial, and we need to find the solution. Okay, just remember it has power 2. Okay, so there are 2 solutions for it. Okay, so number of solutions depends on the degree of the polynomial. Here the highest degree is 2, so it has 2 solutions. Means the values, if you put these values, the polynomial becomes 0. And time being you take x, here you take the value of x, this is y, means this is what? Px. You take minus 2, minus 1, 0, 1, okay, 2, 3, 4, etc. Okay, you can start from minus 2, minus 1, 0, 1, 2, 3, 4, and if you put these values, the polynomial become 6 here, here 0, and here minus 4, here minus 6, and here also minus 6, and here minus 4, and here 0. Okay, so there are two values, that is minus 1 and okay 4, for which the polynomial becomes 0. So it has two solutions. If you plot these values in the graph, it will give a parabola. Okay, parabola. What is parabola? See, this is Cartesian coordinate systems. This is x and x dash, and this is y and y dash. Okay, so parabola will be in the form of, it is like this. Okay, it is like this, and it is symmetrical about y and y dash axis. So the parabola cuts the x axis at two distinct points. Okay, and these points, that is, one is minus 1, this point will be minus 1, and for which y will be 0, and this will be 4, 1, 2, 3, 4. Okay, this is 4, 0. So at 2 points, minus 1, 0 and 4, 0, the parabola cuts the x axis, and these are the two solutions, minus 1, 0 and 4, 0 for the quadratic polynomials. Okay. So sometimes the graph may be like this. Okay, you take, this is the quadratic, this is the Cartesian coordinate systems. Sometimes it is like this, and this is known as what? Hyperbola. Okay, but if the parabola doesn't cuts x axis, take the example of like this. This is another Cartesian coordinate systems. If it is like this, it doesn't cuts the x and x dash. Okay, means you have to say that this quadratic polynomial has no solution. Okay, quadratic polynomial has no solution. Got it? So these are the basics about the graphs of quadratic polynomials. Okay, and one more case. You take if the Cartesian coordinate system in Cartesian coordinate systems, you take, this is parabola. Okay, so it touches x and x dash. Okay, only in single point. Then you have to think that here both the roots are equal. Okay, both values are equal, but don't think that it has only one root. It has also two roots. Quadratic must have two roots, but both roots are equal. Okay. So this is about the polynomial. So I want to give you the homework. You will do the exercise 2.1. 2.1. Here, see, the graphs of y equal to px are given in the figure 2.10 below. For some of the polynomial px, find the number of zeros of px in each case. Okay, so you will find the number of zeros studying the graphs of the polynomials. Okay. Next, I will discuss how will you form quadratic polynomial or equation if two roots are given, means two solutions are given. Okay. And how the sum and products will be related to coefficients. Okay. Thank you.